So for the next 20 minutes, I'm going to hand you over to an expert in the field of using the digital railway to optimize your assets. That sounds very interesting. So perhaps you can tell us exactly how we optimize our assets. Mark Aston.
Thank you very much. Thank you very much. Good afternoon, everybody. So yes, the talk today is really a little bit about how do suppliers, manufacturers and operators of rail networks translate this magical term digital railway into something that is useful and actually benefits both the operability of the railway, the running costs of the railway and the passengers that use it. So we all know that railways are predominantly from a pre-digital era, and traditional track and infrastructure maintenance is very much focused around the preventative side of maintenance and ensuring optimum operating conditions by regular track walks, regular inspections of equipment, and historic understanding of the use of consumables, etc. However, the magnitude of the physical number of miles of the railway makes this quite an arduous task. And if you consider the need to provide a smoother, more provision service for commuters especially, Network Rail and many other train operators around the world are very much looking for the ability to run trains reliably closer together without compromising safety and security. So the way to really consider this is actually take away the manual part of maintenance and asset support and turn it into a digital collation of data from these assets. From that collation of data, you can provide analytics that give key performance indicator targets for maintenance teams, for operators, and you know more about what your railway is doing, when it's doing it, and what needs to be maintained to ensure it carries on doing it in the best possible manner. Big question for suppliers on a whole is, how do we provide management of connectivity, particularly in legacy products which may not have had a network connection, may not have 3G, 4G or Wi-Fi communications? In that case, how do you upgrade the equipment to be connected? And then how do you provide analytics that are useful to the end customers, the end operators of the railway network, to actually make best use of the information that you can now provide? So traditional methodology is evolving, and so are customer expectations. If I use the example of our solid sticks that we use for friction management on trains, they're very much a consumable. They make the wheel-rail interface as efficient and as optimum as possible in terms of the power used for trains on the track, and also the avoidance of adverse noise in gauge face and top of rail grinding. The LB Foster trackside friction management, however, have connectivity built in, and we already provide a range of software solutions that take the data from the trackside consumables where we pump friction materials onto the rail and can tell you when they're becoming low enough to require refilling. If we take that philosophy on board and provide connectivity again to the onboard methodology, then again you can start to increase the level of data gathering about what you're doing in terms of use of consumables for friction management and the use of those in operating the train. Other examples are customer information systems. Traditionally, they've connected to a TOC-by-TOC service. So every TOC has had their own servers, their own data gathering. They use Darwin, they may use their own timetable planning, they may use a national timetable planning. But nothing is traditionally all bundled together, so you have interoperability of information between each individual TOC that may run on a particular line of track. And for those of you coming up to Birmingham today, we've got Northwestern trains and we've got Virgin. It's sometimes a little confusing to know which ticket you bought to go on which line. And this is all about how do you provide that information to your end customers, and how do you ensure that even the CIS is completely transparent to everybody that uses the rail. Safety and security is an increasing need as well. If you're going to run more trains or longer trains and run them closer together, then you need to have confidence that you're not compromising the security and safety of passengers in doing it. And you also need to ensure that you're not going to compromise the security of people who may use infrastructure near railways, such as pedestrians on level crossings or cars that may stall on a level crossing. And passengers, they're the key reason we run a railway. And they have more expectations in this 21st century digital age of using mobile apps. They look for digital ticketing because it's there, it's something simple, they don't have to go to a ticket office. They want end-to-end journey planning, nationalrail.co.uk, the TOC sites, LUL's journey planners. They also want the most cost-effective way of achieving their journey. And I'm sure you're all aware that RSG have been working on how the strategic elements of bringing together the most cost-effective ticket prices as an available option for all routes is naturally integrated into the rail ticketing system as a countrywide aspiration. And underlying that, they want complete protection against the differences from TOCs in doing so. It doesn't matter whether it's North Western Railways or Virgin. If you want a fast service, you buy a ticket, it's fast service, it gives you a Virgin train, but it shouldn't be all about that. If you're happy to pay the best, most cost-effective price, but you still have a time constraint, then you need to make the judgment of whether it's North West or Virgin and have those options presented to you in an application. So, in terms of the railway itself, assets are increasingly capable of digital connection. They come with some form of internet connectivity, whether it be a bespoke wide area network connection, 3G, 4G comms, Wi-Fi, trackside telecoms. The ongoing philosophy for Network Rail is to increase the ability to benchmark the railway system to make Network Rail's managed rail system the best in the world. By 2024, extend the use of asset management to achieve industry-wide systems and processes. That's a big statement. And it's the same thing that we're coming across in our global territories. North American Class 1 freight, it's the same. How do you optimize your rail operability? In Europe, Deutsche Bahn are embarking on the same philosophy and strategy as Network Rail, so are Trenitalia, so are Spanish railways, so are French railways. To achieve any of those goals, it needs to be a holistic, network-wide enablement of railway service and supply of equipment that is capable of being analysed remotely and reported. And that comes down to the provision of data analytics. A digital railway means that all discrete assets, friction management, infrastructure, CIS, needs to be addressed via IP networks, all of the comms that I've previously mentioned. But it relies on three things: the gathering of timely asset information, how you analyse that information in terms of what does it give maintenance teams, what does it give infrastructure management teams, what does it give the operability teams. And it needs a seamless interface of that information into the control systems, just as an accounting system might integrate into an SAP application. You very much need to consider how you gather and integrate those sources of data, the analytics that provide them, into the large operating systems that companies like Siemens, for example, sell and use to operate the whole network on railways. I'll introduce our anatomy suite as an example of how we're trying to tackle this as a 21st century problem. Anatomy is a suite of software that comprises asset management, integration into customer systems, inspection via portable devices for mobile teams to go out there, take their phone, have an app on there, take pictures, take GPS coordinates of joints within trackside signalling that perhaps the cabling is buried within a channel and you wouldn't know where it physically is unless you opened up all the channel routes. We have the reporting for customers. This is the key thing. Each customer has a different set of requirements. And not only customers, but staff themselves need to understand how their job is affecting the correct operation and the timely operation of the network. And underpinning all of that is you're going to have some warehouse maintenance here. So you want to know about your part stock management. You don't want to hold too much capital equipment in stock. You don't want to run out of spare parts for a critical part of the infrastructure that's going to mean trains run slow for a couple of days while it's delivered. All this now is available in a pretty well-packaged solution, and we use particularly the asset management in our own friction management products, particularly RPM2. We've implemented this in adjacent industries as well, including social housing, where each house has a number of assets. And the lovely thing is, an engineer might replace a component on a boiler, and he might do it every month for 6 months. Because he's just given the job sheet, he wouldn't know necessarily that there's an underlying cause. He's just replacing a component. With analytics, you can see that that is not the replacement cycle that you should expect for that component. Therefore, there's either something wrong with that batch of components, the component is not spec'd for that system correctly, or there's an underlying cause that needs to be fault found before you actually replace that individual component again. Exactly the same philosophy applies to all of the trackside and infrastructure assets that you have on the digital railway. So Fingerprint is the maintenance part of this. This is where you can actually go out and gather data about your assets. You can do your track walks, do service maintenance. You can automatically scan your barcodes on trackside equipment, see where the consumables are being used, see what the cycle of maintenance has been, whether it's increasing, decreasing. It's managing your lifetime asset cost, because you don't need to visit it until that software tells you that you need to schedule a visit to go and see whether it's working appropriately or not. And Brainwave, this is the lovely bit. Although you can't see this, the point is we can configure very clean reporting sheets that tell you exactly what you need to do over the next week, the next month, the next quarter, the next year, the next 2 years in terms of your long-time asset life. If we consider that the target for most infrastructure assets is a 10-year life cycle, you want to maintain them effectively over that 10 years with minimum lifetime cost or optimized lifetime cost, that you don't visit a site, say, with a consumable, only to find that that consumable is still half full in the tank. You only want to replace the consumable at the point where it needs to be refilled. Otherwise, it's a partially wasted journey. You can save costs by planning and using the analytics of history on the data that you gather to effectively manage your asset cost. Heartbeat. One of the biggest things we encounter, both as a company and for our customers, is the actual ability to report back to everyday members of staff what you're doing, how you're doing it, and what the effect of their hard work is in optimizing your business. This, I think, is quite frequently forgotten, and certainly in terms of a digital railway, you want to be able to instill that sense of passion in the maintenance teams, in the track service teams, in the train operating companies, in the head offices. And this is a very important part. If we consider the point I made earlier about footfall through stations, really passengers want to know about their journey well before they have to leave their house. They want to know whether or not there's any delays in either parking at the station or there's any delays through their normal train service if they're a commuter, what the knock-on effect of engineering works might be. And also we want to increase the more automatic provision of information for station staff, like suicide watch and security surveillance. There's a lot of clever analytics in the products we sell for CCTV now that can determine loitering time. They can determine state of mind by facial feature. It's not a wholly proven science and technology yet, but it's there in provable form that can help provide information to both British Transport Police and station management. And we look at smart passenger information as the holistic journey from a customer's home right the way through to their destination. In LB Foster product range, it talks about journey planning. It's the customer information, ticketing, wayfinding, footfall management that I've mentioned in our CIS projects. It's the journey efficiency, which is the telecoms, the infrastructure, the signalling and rail friction management. All of these have an end-to-end, holistic application to the digital railway. If we integrate all of these, not only as our company, but as part of your rail systems, and all competitors have an approach to integrate their products into a similar network, then your passengers know where they're going to be going and how they're going to get there, and you know where the hotspots are to manage footfall. And station displays can become a lot more interactive than they used to be. As you walk through a station, you can talk about what your end journey connections might look like. You can tempt people into the retail units. You can tell people where they need to go for their onward journey if it's not rail. You can manage more their effective appreciation of what's going on the platform, and even make clear evacuation and safety messages part of the very CIS rather than just the klaxon and the normal evacuate station now. It leads us into a total asset management philosophy, and one of our interesting products is LiDAR. We use it for levels crossing safety with signalling control and incident management and red light enforcement to enforce the penalties for people who ignore the wig-wag signals. We've taken that consistent product and also looked at it for earthwork and retaining wall monitoring. I'm told by Network Rail Geo Team that 87% of all UK assets in embankments and retaining walls require maintenance over the next 5 years. In what order do they prioritise that so that there isn't a critical failure of an earthwork that stops trains running? Well, we can monitor that with looking at how the toes of embankments move over time. Network-wide CIS for station and commuter footfall feedback. How do you operate your station to the best effect? Signalling control that integrates with heritage mosaic panels and digital system feedback. That's important because it's the operation of the railway, and it's feeding that information back on the CIS for disruption management screens, for journey planning, for wayfinding. And I mentioned remote condition monitoring earlier. Trackside friction management is a big worldwide seller for us. These are the units that make the rail work as effectively as possible, as noise-free as possible. Digital control units have been on the system now for a good few years. Avalanche and landslide monitoring. Here, remote sensors that tilt when you have a mudslide or an avalanche hit them. They report back to a central server that can then give you analytics about what's happened, where it is, whether the track has been compromised, so you can do something about it rather than a train just arrive at a blockage and then report back to base. These have exceptionally long battery life, and they are completely wire-free. They're a very cheap, cost-effective way of monitoring what's happening in remote locations, and therefore you're going to save cost on your asset because you know what's happening to the rail in the event of an adverse geological event. Flood monitoring, it's a big one in India, it's a big one in Mexico at the moment. It's important to us. We can do day-night monitoring, we can give level monitoring, we can do all sorts of asset monitoring in terms of cisterns, tanks, sluices. etc., to prevent washout of railways by too much groundwater accumulating before you need to get rid of it. Rockfall, similar. If you've got a very steep cliff, as they have here in this example, you may have a rock end up on the railway. You need to clear that before trains can run effectively. This system again uses our LiDAR to give you complete total track monitoring of the state of that rail and whether or not there is a blockage or not. It may be that a rock falls off and rolls across the track. If it's off the track, you don't need to send the maintenance team out immediately. If it's on the track, you do. With this, you can tell how big the rock is, where it is, and what action needs to be taken. Wheel load impact detection and also smart wheel sensing. The wheel load impact detection, if you're running TOC trains or customer train sets on your railway, you want to make sure they haven't got out of true wheels that are damaging your rail as an asset. Wheel load impact detection is a product that tells you exactly what that wheel is doing as it passes over it. And the smart wheel sensing as well can also give you elements of detection of number of axles, number of wheels. We have done weigh in motion. That can also be used for understanding the fill, the capacity of carriages for transit and passenger systems. So it's a very flexible approach to making sure you have all the information you need to make sure that nobody's damaging your asset and you're maintaining your assets effectively. Our remote surveillance and security is very much targeted at not being a Me-Too security camera. This is a camera that only works off solar power and remote telecoms. It can be installed anywhere, temporarily or fixed. It's great for laydown sites, for trackside infrastructure works. It's great for protection of bungalows and signal housing. It's also very good for doing intruder detection and grabbing images that can be used for prosecution without people necessarily knowing that they have been caught. And because there's no wires to cut, there's no way they can get around this security system. It is very good in terms of what it does. So all of this impacts on the digital railway by giving you the ability to efficiently manage the maintenance of scheduled parts and warehouse parts in a timely manner. It allows individual assets to be better monitored to predict the consumable needs and maintenance requirements. Gives you a smoother running railway that allows a higher density of train sets on track. It's going to be a better passenger satisfaction, better rail cost utilisation as a whole. It will reduce the number of major critical infrastructure failures. They don't happen very often, but when they do happen, it's a problem. It allows you to better plan your budget spend from a year-to-year and future upgrade scenario. It allows better management of the passenger experience and safety because of this. It gives you cost savings on rail inspections, track walks and general inspection. And because we're incorporating digital communications, data gathering and database analytics, we're going to be able to serve a global network of railways in this arena. So what next? Well, all of the suppliers and the users of this type of digital analytics and digital asset monitoring require a common approach to a communications protocol, and it needs a defined security protocol. It needs something that is going to be as hacker-proof as possible. Penetration trials need to be undertaken for sensitive networks, and we need to have a unified approach to data collection and analytics that allows review of data from the legacy assets and systems. Importantly, provides the analytics for asset management and maintenance, provides the automatic scheduling of maintenance, spares and consumables, taking the load off the warehousing activities, and take the uncertainty out of monitoring aging assets such as earthworks, retaining walls, and other such historic foundations of the rail network. And we have to get a bit of a sales message. So, we are absolutely committed. CP6 starts this year. we have got a 5-year program to ensure that all of our products, whether they be remote condition monitoring or otherwise, are fully digitally enabled, backed by LB Foster systems that can be integrated into any of your systems at all, and take the railway that was created over 100 years ago into a 21st century plus scenario. We'll just finish on a little video. So thank you very much for your attention today. I'll take questions as you have. The touch points of LB Foster within our world that keeps it moving, from aircraft to power stations to train to rail to safety and security to geological activity. Thank you.